to 10, and I'm going this way because we have hours and money, right? You can't do hours to hours and money to money. So hours to money. 2 is to 10 as 3 is to 15. All right, well, cross multiply. 10 times 3 equals 2 times 15. Does it? Oh yeah, 30 equals 30. So an equation with variables that are directly proportional has this form. Don't get scared. It's not hard. Y equals kx. K just means the constant. Here, in this example, $5 was the constant, correct? However many hours I worked, I earned $5 per that hour. So 5 was the constant. It did not change. All right. Let's look at the next thing. Ugh. Why can't I just flip pages? Good grief. Because I'm slow. All right. Which is not an example of a direct variation? The lengths of the side of a regular hexagon and the perimeter. Well, do those two directly correlate? Yes, right? The length, and you add all the lengths. Of course it's going to be proportional. The number of books in a stack and the height of the stack. Well, if I have 3 books, they're going to be 3 books high. If I have 2 books, they're going to be 2 books high. So yes, they are proportional. The speed at which you travel to school and the time it takes to get to school. Well, let's think about that. Let's say I can go 40 miles an hour. Is that the only variable? No, there's going to be stoplights, there's going to be traffic signals, there's going to be pedestrians. This is not a direct variation. How about this one? A length of a segment in inches to its length in centimeters. Well, yeah, that's set, right? We know that every inch is 2.5, or every centimeter is 2.5. How's that go? Every inch is 2.5 centimeters. All right, 2.54. All right. The graph of a function with a direct variation is always a straight line or array that includes the origin. So which of these would be a direct variation? Only B. That's right. That's the only one that's a straight line that includes the origin. This one is just off. This one's all wackadoodle, and this one's way off. So this is the only one that's a straight line or array and includes the origin. So if you see that, you're going to know, oh, that's a direct variation. All right, let's look at some more. Inverse variation. Don't get scared. Don't get scared. New words, not hard. Inverse variation is a relationship between 2 variables in which a change in one variable results in an inversely proportional change. What? For example, one variable doubles times 2 and the other is half times the reciprocal times 1/2. All right? Rate and time are an inverse variation. We have rate, we have time, we have distance. This would go to if I travel 40 miles an hour to school, and what time will I get there, right? Now, the distance is the constant. From my house to school, the miles never change. It's always going to be 10 miles to school, right? The rate and the time are the variables. How fast I go and how long it's going to take me. Distance, it's always going to be 10. So the rule is, or here, we'll do an example. Well, here's the equation. Rate times time equals distance. So let's say Adam travels 2 hours at 60 miles per hour. There's the time, there's the rate. So you're going to multiply these two, right? Rate times time. Distance is 120 miles. That is my constant. So I can change my variables as long as they multiply and add, or multiply and give me the answer of the product of 120. So 60 times 2, yep, 2 hours, 60 miles, that equals 120. What if I then went 40 miles? How long would it take me? It would take me 3 hours, because 3 times 40 is 120. What if I only went 30 miles an hour? Then it would take me 4 hours, because 4 times 30 is 120. Remember, my miles aren't changing. I need to go from point A to point B. That's not changing. What if I only went 20 miles an hour? It would take me 6 hours, because 6 times 20 is 120. So how are you going to graph this? Because it's going to look weird if you ask me. Easy peasy lemon squeezy. Remember, here's our proportion here. Here's our coordinate points, right? All right, so I have rate, miles per hour, and I have time, my hours. And to make this all fit, I went by tens, right? So 0, 10, 20, 30, 40, 50, 60. Now, if I were to, or when I did graph everything, at 2 hours I was 60, 3 hours I could only go, it took me 40 minutes, or in 3 hours I could only go 40 miles an hour, 40 miles an hour took 3 hours, 30 miles an hour took 4 hours, 20 miles an hour took 6 hours. And look, it's always a curve. An inverse proportion is always a curve, never a line. All right? Now, why are we doing this? Because they're going to ask you these kinds of problems, these work problems. Oh, they love work problems. So listen up. Work problems also involve measures that are products. Example, Rafi and one friend can roof the whole house in 24 hours. Okay, Rafi and one friend, that's how many people? 2 people. It takes 24 hours to do this roof, right? Right away. Okay, what's 2 times 24? Well, that's 48. Okay, I need to know that because everything I write is going to equal 48. The product is always going to be 48. So now, how many hours would it take Rafi and 2 friends to roof an entire house? All right, so I got 3. Well, 3 times what is 48? Well, divide 3 into 48. Let's do that in a minute. 3 goes into 48, goes in there once, you get a 3, you get, oh, look at that. Whoops, 18. So 16. So if they had one more friend, they could do it in 16 hours. Let's say they had Rafi and 3 friends for 4 total. Well, 4 times what is 48? 12. 12. It would only take 12 hours. All of these equal 48. Get it? See, that's not so bad, right? Okay. On 2 more. I want you to copy the following to turn in for your investigation. If 3 people can harvest a field in 8 days, how many people are needed to harvest the field in 2 days? All right, so if 3 can do it in 8 days, right? What's 3 times 8? That's 24. So if I want 2 days, right? Because I got to remember, this are my days. These are my peeps. So if I have 3 people, it takes me 8 days. I want to do it in 2 days. Well, 2 times what is 24? 12. So it would take me 12 people. All right? We can also use the inverse variation to help us multiply numbers mentally. What do you mean by that? Okay, first have, or take half of one of these numbers. Well, this is going to be the easiest one, right? Half of 24 is 12. Because I took half of this, I'm going to double this, right? Half and double, remember that, times 2 times a half. So 2 times 15 is 30, so now I have 12 times 30, and I can think to myself, oh, well, 12 times 3, I know that, that's 36. So 12 times 30 is 360. All right, so what about this one? Find the product 25 times 18 using this method. Well, 18 is the easiest one to split in half. That would be 9. And then this would be 50, right? Double that would be 50. Well, 9 goes in, or I'm sorry, 9 times 5 I know is 45. So 9 times 50 is going to be 450. See, that does make it easier, right? Easy peasy lemon squeezy. That is investigation 9. I will come back for lesson 91.